We're back and ready to build our level again. Between recordings, I closed the editor after saving everything. When I reopened it, I was greeted by a black screen that might look a bit alarming. But nothing is broken. This usually happens when the level file gets moved to a different location. I placed everything inside the template folder. To bring back our third-person level template, I just need to go into the third-person map section. Then I'll find the third-person map and double-click it. This file is our actual level inside the content browser, and it holds all the data for the scene you're seeing here. If you moved it like I did and you reopen the editor to a black screen, don't worry, just find the level file in the content browser and open it again. That restores everything immediately. But if I close Unreal and reopen it again, I'll run into that same black screen. So let's fix that properly so it doesn't keep happening. To stop this from happening again, we need to change the default map that opens when the editor starts. Go to Edit Right Arrow Project Settings. This will open the settings window. From there, scroll down to the project section and open Maps and Modes. Under Default Maps, find the option called Editor Startup Map. Now select the third-person map. At this point, it should be the only level in your project. Set that as both the editor startup map and the game default map. Once that's done, close the settings. Now restart Unreal Engine. You can open the project again either from the launcher or by double-clicking the project file if you know where it's saved. When it reloads, everything should open correctly. When we reopen it now, it loads straight into the third-person template map. So that's a quick fix to keep in mind. If you ever move your level files or change your folder structure, you may need to manually point Unreal back to the correct map so it knows what to open. But even though this third-person template is working fine, we're not going to stick with it. We're going to build our own level from scratch. To create a new level, go up to File and click New Level. A small window will pop up with a few template options. These decide the type of level you want to start with. The first option is Open World. It comes with a landscape already set up, along with World Partition enabled for large environments. World Partition is outside the scope of this course, but in simple terms, it's how Unreal splits a large open world into smaller sections to help keep performance stable. This open world template also includes things like a sky atmosphere, which gives you a basic sky setup, and a directional light, which acts as the sun. The empty open world option, on the other hand, gives you World Partition already set up, but without the landscape, sky, or lighting included. We're not going to use the open world templates here. The next options are Basic and Empty Level. The Basic template comes with a simple setup already in place, like a sky, a directional light for the sun, and a basic floor so you can start working right away. However, it doesn't include any of the large-scale open world systems, since those aren't needed for our project. We're going to choose the Basic option. The empty level is exactly what it sounds like. It starts you off in a completely blank space with nothing in it. You'd have to add everything yourself, including the sky and lighting. Instead, we'll stick with the default Unreal Sky setup. So go ahead, select Basic and click Create. I mentioned earlier that this scene is made up of actors. In Unreal, any object you place in the 3D viewport is called an actor. So when I say actor or object, I'm talking about the same thing. Right now, I've just opened the outliner so we can see what's in the level. Inside the outliner, there's a folder called Lighting. You can collapse that. If we look through it, almost everything belongs to the lighting setup. The only exception is the floor mesh, which is just there so our character has something to move around on. But if I hit play right now, you'll notice something's missing. We're not spawning as the default character, and that's something we definitely want to fix. Let's figure out why that's happening. The first thing I notice is that there's no player start in the level. So we need to add one. Go to the Place Actors panel and under the Basic section, find Player Start, then drag it into the scene. You'll see a small marker appear in the viewport. That's the spawn point. This simply defines where the player will spawn when the game starts. But even after adding it, we still aren't getting the third-person character, which is a bit odd. To fix that, we need to set the correct project defaults. Go back to Edit Right Arrow Project Settings, then open Maps and Modes again. Now instead of staying on Maps, switch over to Default Modes. Right now, the default game mode is set to None, which is why Unreal doesn't know which character to spawn. Open the dropdown and select BP third-person game mode. Close the settings and press play again. This time, the third-person character should spawn correctly at the player start location. Quick side note, you don't actually have to use the player start if you don't want to. Another option is to go into your third-person character blueprint and drag it directly into the level. Then, with it selected in the Details panel, search for Possess. You'll see an option called Auto Possess Player, which you can set so the character is controlled automatically when you hit play. If you set it to Player 0, you're basically telling Unreal that this character belongs to the first and only player in the game. Since this is a single-player setup, Player 0 represents the main player by default. Now when you hit play, you'll still be able to control the character, even without using a player start. To show what's happening more clearly, if I set this back to disabled and add a player start again, you'll notice something interesting. We can still see the character blueprint in the level, but we're no longer controlling it. So if you ever want to manually control a specific character without changing the game mode settings, this is the method you'd use. You could also just drag the character in and set Auto Possess Player to Player 0. For now though, we'll stick with the player start setup. That works perfectly fine. At this point, everything is running correctly, so let's move on and take a closer look at what our level includes by default. We already looked at the floor, and now that the folder is collapsed, it's much easier to see everything. We've got the player start actor in the scene as well. Under the lighting section, there's a directional light which acts like our sun. If we disable it, the entire scene immediately goes dark. This single light is what controls all the illumination in the scene. We also have exponential height fog, which you can toggle on and off to see its effect. It creates that atmospheric fade in the distance, giving the world depth, especially in outdoor environments. Then there's the sky atmosphere, which handles the look of the sky itself, like the soft blue backdrop you see behind everything. We also have a skylight, which affects how lighting and shadows behave in the scene. To demonstrate it, I'll quickly add a couple of cubes and scale one up. You don't need to follow along here, this is just to show what the skylight is doing. With these objects in the scene, you can notice that even the shadowed areas still pick up some brightness from the environment. That's the skylight simulating indirect light, similar to how real-world shadows still get some bounced light. If we turn the skylight off, the difference becomes much clearer. When we disable the skylight, the shadows become completely dark, which doesn't look very realistic for an outdoor environment. That's exactly what the skylight controls. Of course, all of these settings can be adjusted and fine-tuned, but for now, we'll just keep everything at the default values. We also have the sky sphere, which is the actual dome mesh that wraps around the level and creates the sky backdrop. Along with that, there's the volumetric cloud system, which handles the clouds you see in the sky. If you disable it, the clouds disappear. For now, we'll leave all of these at their default settings. If we need to adjust the lighting or atmosphere later, we can always come back and fine-tune them. Now I want to talk about prototyping. The first thing I'm going to do is drag in one of the blueprint characters, not for gameplay, but just to check scale. When you're building or blocking out a level, you always want to design around the player's size. Otherwise, you could end up creating a huge, detailed environment that doesn't actually feel right in-game. And then when you hit play, you might realize the character can't even fit through the doors. That's obviously a problem. To avoid that, it helps to keep a character mesh in the level while you build, so you can design everything to proper scale from the start. There are also a few different ways you can prototype levels directly inside Unreal. The first method we'll look at is using the level prototyping cubes that come with the third-person template. I'm going to open the content browser and dock it so it stays visible. Then I'll go into the level prototyping folder, open meshes, and here you'll find a set of basic mesh blocks. These should look familiar. They're the same pieces used in the original third-person template map. You'll notice they all start with S. In Unreal, SM is just a common shorthand for static mesh assets. Unreal uses these naming conventions to help identify what type of asset something is, along with a basic description of it. You don't have to follow the same naming style for your own meshes, but it does help keep your project organized. Now let's take one of these cube objects and drag it into the scene. Just place it anywhere for now. This prototyping cube is really useful. It's a simple shape you can easily adjust, and it already has a grid material applied to it. That grid makes it much easier to stay aligned with Unreal's built-in grid system. And that matters a lot during early prototyping because you want everything snapping properly into place so you don't end up with small gaps in your level where the sky or light can leak through. Each of the larger grid divisions represents 1 meter, and the smaller divisions are about 20 centimeters. Now if I scale this cube up, you'll notice something important. The grid material doesn't stretch. Instead, it keeps repeating across the surface. These cubes are really helpful for keeping track of scale while you prototype your level. For example, if I stretch this box out, I can quickly tell it's about 3 meters by 4 meters just by reading the grid. So when we look back at our level plan from pre-production, we know we'll need wall pieces that are around 4 meters in size. I picked 4 meters because that's a very common modular size for wall pieces in games. So I'm going to scale this mesh until it matches 4 grid units in length and then scale it up to 4 meters in height. Now I've got a simple square wall piece that we can use as a solid base for building our level. If it feels too thick and you can't really make it thinner without it breaking or looking off, you can adjust the scale increments. Set the scale step down to 0.25 instead of larger jumps. That gives you finer control so you can make the wall a bit thinner and more precise. Now we've got a properly shaped wall piece ready to use. If I want to extend this and build another wall, I can simply hold Alt on the keyboard. Then I click and drag one of the transform arrows and it automatically creates a duplicate of the wall. This makes level prototyping really fast. You can quickly block out spaces, test layouts, and get a clear sense of scale. Now I can even hit play and run through the area to see how these wall pieces feel in-game. However, there is a downside to using these for prototyping. Because I duplicated this cube, both walls are still instances of the same original mesh. In other words, they're linked and share the same base asset. So if I needed different wall sizes, like one that's 2 meters tall and 4 meters long, I can scale them individually and they'll look correct in the level. But when it's time to replace these placeholder walls with final art assets, this setup becomes a problem. Both pieces are still referencing the same original cube asset. That means they're not truly independent. So if I change something on that master mesh, those changes will automatically affect every instance of it. And in many cases, that's not what we want, especially when each wall piece needs to behave as a separate, unique asset later on. For example, if I double-click this cube, it opens up in the static mesh editor. This is a separate window where you're now editing the original master static mesh itself. Any changes made here will affect every copy of this cube used throughout the level, since all of them are referencing the same source asset. So if I go in here and change the material to something like blue, then save it, you'll see that the change applies everywhere. Both walls update at the same time because they're still using the same base mesh. And if we needed different materials for each wall, this setup doesn't really allow that separation. So I'll switch it back to the original material. Also, keep in mind that the sizes we adjusted are all relative, not unique per object. So again, if I look at the scale values, you'll notice those unusual numbers we set earlier. If I reset everything back to a scale of 1, the cube returns to its original default size. That's because these adjustments are just per instance changes in the level. They're temporary and don't actually modify the original mesh file itself. That's why we need separate assets for different sizes and types. Right now, everything is still pointing back to the same mesh. So when we eventually swap these placeholders out for real art assets, we'd basically have to rebuild parts of the level manually. And ideally, we want to avoid doing the same work twice. We want to build the level first and then later simply swap out the placeholder meshes for final assets. That way, all instances update automatically and we don't have to manually replace everything one by one. So with that in mind, let's remove this for now. The second way we can prototype our level is by using a BSP volume. To do that, open the Place Actors panel and keep it pinned open for now. Then switch over to the Geometry tab. Here you'll see a set of basic blue primitive shapes. These blue shapes are different from static meshes. They're BSP volumes instead of regular assets. A BSP volume is basically a shape you can drag into the level like a mesh, but it's not actually a static mesh. Instead, it's editable directly inside the editor in real time. That means you can select it and transform it using the same tools you use for static meshes: move, rotate, and scale, just like normal level objects. On top of that, we can go up to the Select Mode dropdown. If we switch it to brush editing or just press Shift+7, we get access to the brush editing tools. This lets us directly modify the shape itself. For example, we can select individual faces of the BSB and move them around, like pushing a surface up or pulling it inward. We can even select a single point and adjust it independently. With BSB volumes, we're able to build more complex shapes than we could using basic primitive cubes alone. We can also change the pivot if we need to. So for example, even if this is the final shape I want, I can set it to pivot around a specific point instead of its default center. What I can do here is select that point, right-click and choose Set as Pivot Offset. Now the object pivots from that spot instead of the center. That's another reason BSB volumes are useful. They're more flexible. You can shape them more freely and even adjust the pivot, something you can't really do with standard static meshes in the same way. For example, if I wanted the pivot to sit in the middle, there isn't a straightforward way to do that even in the static mesh editor. Another useful thing about BSB volumes is that you can convert them into static meshes later on. So I'll duplicate this again by holding Alt and dragging one of the transform arrows to create a copy. Let's jump back into brush editing and tweak the shape slightly so the two pieces don't look identical. Nothing too extreme, just small changes so they're a bit different from each other. Alright, I've kind of made a mess of that one. I went a bit too far. Let me just create a fresh one and edit it more carefully this time. Now they're slightly different from each other. Since these are BSB volumes, not static meshes, they aren't tied to anything in the content browser. So even though I duplicated and edited them, they're still fully independent objects in the level. What's nice is that I can select one of them, and I don't even need to stay in brush editing mode to do this. With the brush selected, go down to the Details panel. Open the Brush Settings section, then expand the Advanced options. Inside there, click Create Static Mesh. A window will pop up asking you to choose a save location. This is where Unreal wants to know where to store the new asset in your project. This will generate a new asset file for it. When choosing the location, make sure it goes inside the content folder. Everything in Unreal needs to stay under content, nothing outside of it. I'll name it BSB Shape 1 and click Create Static Mesh. Now this BSB has been converted into a proper static mesh asset. So now I can't edit this with the brush editor anymore because it's no longer a BSB brush, its shape is now fixed. But if I go into the content browser, I can see it has been saved there as a proper asset. I can do the same thing with the other one as well. I'll name it something like BSB Shape 2 and create it the same way. So now we've got two separate asset files for these two meshes. That means each one is its own independent static mesh. If I change something on one, like applying a different material, it will only affect that specific asset. Even though they started from the same BSB and were duplicated, they now have separate file paths, so they're no longer linked. This is really powerful because it means we can build our whole level using these prototypes and later swap them out for final art without having to rebuild everything from scratch. This will make a lot more sense once we start creating and importing our own custom assets. Of course, BSB brushes do have some downsides. For example, once we convert a BSB into a static mesh, we lose the ability to edit its shape. At that point, the geometry is locked in and can't be adjusted anymore. So if we needed to change it later, we'd either have to open it in a 3D tool like Blender and modify it there, or recreate the BSB from scratch and replace it in the level. At this point, you might be thinking, why not just avoid converting it to a static mesh altogether? For example, let's drop in a BSB stair just for demonstration. You can tell it's a BSB because the vertices are visible. That's what shows it's still a brush and not a static mesh. Even so, when we press play, we can still walk up it and interact with it normally. And once we convert it into a static mesh, we can actually lose or need to rework the collision setup. So at this point you might wonder, why convert it at all? The reason is performance. BSB brushes are great for quick, flexible prototyping, but they aren't efficient for a finished level. Once your layout is finalized, keeping everything as editable BSB geometry can slow things down quite a bit. So typically, you'd convert your BSBs into static meshes to optimize the scene and make it run smoothly. You might start noticing frame drops and performance issues if you rely on BSBs too heavily. That brings us to one final way of prototyping levels inside Unreal. This is a relatively newer workflow introduced around the late Unreal Engine 4 updates and continued into Unreal Engine 5 with ongoing improvements in each version. This is called the Modeling Toolkit. It's still an actively developing feature, so it's not completely perfect yet, but it keeps improving with each update since it's considered more experimental. Because of that, some of its features aren't enabled by default. This is also a good time to talk about plugins and how you can turn extra tools on inside Unreal Engine. So we're going to enable the Modeling Toolkit plugins so we can use them for level prototyping. To do that, go to Edit Right Arrow Plugins, which opens a large list of available plugins. Some are already enabled by default while others are turned off. In the search bar at the top, just type Modeling. We'll find Modeling Tools Editor Mode, which in Unreal 5.02 is usually enabled by default. We also want to enable Static Mesh Editor Modeling Mode. Go ahead and check that option. You'll likely see a warning that it's still in beta and may not be fully stable. That's normal since this feature is still under active development. After enabling it, Unreal will prompt you to restart the editor for the changes to take effect. Click Restart now. If you see a message about unsaved content, it just means you should save your work before restarting. So I'll click Save Selected. Since our unsaved work is the level we just created, Unreal needs us to name it before it can save it anywhere. I'm not going to save it alongside the third-person template maps. I prefer to keep default engine content separate from anything I create myself. Since this is our own level, it belongs in our custom content area. So I'll go up to the main content folder and name the level Pictorial Temple, matching what we planned in our level design documents. Then I'll hit Save. Unreal will close and restart automatically. When it opens back up, it should bring us right back into the editor with the plugin's changes applied. We don't need anything else in here, so I'll just close it. You'll notice it takes us back to the third-person map, which makes sense because we set that as the default startup level. Now let's go back into Project Settings, open Maps and Modes, and check that setting again. This is where we previously set it to load the third-person map when the editor starts. Now we actually have a second level, so let's switch the startup map to the one we just saved. Just keep in mind, this doesn't load the level itself right now. It only controls what opens when Unreal starts. To actually open it, we can simply double-click the level and here we are. Alright, let's take a short break here. And when we come back, we'll start working directly with the Modeling Toolkit.